Hello everybody, I'm back, sort of. You can see that we don't really have my normal setup here, because I'm nowhere near where my normal workbench that you are used to seeing is. So I'm just kind of improvising at the moment. So the lighting might be a little bit off, and as you can see, my workspace is a lot smaller than it used to be, owing to the fact that I'm sitting at a kitchen table. I'll apologize in advance. There will probably be a lot of noises that happen in the background. One is the logging trucks that'll be Jake breaking past, because apparently they don't feel that they have to follow the rules for no Jake breaking within the city limits, and you'll also probably hear one of 3 cats tearing around and causing chaos. But anyway, here we are. This is a TV Be Gone kit. We're just going to do a quick kit build here. I might address some things that have been going on, why my channel hasn't been particularly active, but I'll focus mostly on this unless there's a long period of no discussion that I can talk about something else for a bit. Anyway, so when I first started opening this up, I got a little panicky because I've got all these components and this rather nicely printed PCB, but no instructions. A lot of these kits, you'll look at the PCB and it'll tell you which values go where, but this one does not. But then I looked closer and there's a link here, which is out of date at the moment. But if you go to this link on this particular kit, it'll redirect you to the appropriate spot on the Adafruit website, where it then gives you a parts list and everything you need to build the kit. Oh, pardon me, a little noise in the background here. Where's that power cable? Forgot to plug my soldering iron in, and I'm making a big mess. This thing's falling over, and there goes my multimeter on the floor. Boy, I'm just off to a great start, aren't I? So I'm really hoping to start trying to be a little bit more active on my channel this year. I don't even have my normal soldering station. This is that TS100 soldering iron that I did a review on a little while back. I'll see if I can throw an info card up there about it. But this thing has performed remarkably well during my time away from home here. And yeah, I've now that I've actually really put it through its paces, I'm really enjoying the fact that I own one of these. Anyway, we'll get that turned on and starting heated up. And I'll guess we'll just get started. I've got the parts list here on my laptop, which is just over there, so I'll be referring to that periodically. So the parts are fairly normal. We've seen most of these in previous kits, except for these. I haven't worked with these before. These 2 little guys here, the clear LEDs, are wide beam infrared LEDs, and these little blue guys, bluish guys, I'll hold it in front of the white card here so you can see how they're kind of bluish. They are focused beam IR LEDs. And their purpose will become clear, as it were, in a little bit here. So it doesn't give you a particular order for construction here, so I'm just going to stick with the standard procedure of working from the components that are closest to the board and working up to taller components. So we're going to start with these little guys here. These resistors here, they're brown, black, red, which is a 1, a 0, and then 2 zeros, so 1 k ohm. And the booklet here says they are for R1 and R5. So let's just drop that into R1 and R5. So here. I'm using a new camera that I got for Christmas here. It's the GoPro Hero 6 Black. It's a fantastic camera. I'm still learning how to use it though, so I apologize if I accidentally pull out of shot or if the focus is a little bit weird. Still learning, and the only way I can really learn the vagaries of the camera is to actually use it. So we've got that one in R1. Now let's figure out where R5 is. That's over here, so do that. Now this mat I'm working on, it's another Christmas gift. It's a little silicone workbench cover. It's pretty neat, although it's kind of small. It's got a little ruler here, not entirely too sure what that's for, and little pouches along the perimeter that can be used for holding parts or whatever. I'm sure I'll figure out ways of utilizing it later. Oh, there's a smell I've missed. I haven't worked with a soldering iron in a little bit. Love the smell of rosin burning off of solder as you heat it up. Which is what this smoke is. Everybody says, oh, you're inhaling lead fumes. Not really. Okay, today's awkward jump cut was brought to you, I think, by GoPro voice activation. Not too sure what happened there, but yeah, it was in the middle of talking about... I'm just going to adjust the angle on the camera here a little bit. There we go. I was in the middle of talking about how... whoops, I just burnt the table. Sorry, Matthew. I was in the middle of talking about the smoke from solder, which I've talked about before, but it bears repeating. You're not actually breathing in any lead. That smoke is the burn off of the rosin, which is actually a basically glorified pine tree sap. Something about the components in it cause solder to wick more easily onto the pads and wires. So interesting little factoid there. I've mentioned it before, but just in case you're new to these things. All right, so I think the next component we'll place here will be C1, which is this little tiny ceramic 0.1 microfarad capacitor, 104, so 10 and then 4 zeros, which is going to be 100,000 picofarads, or 0.1 microfarad. So we'll just flip that over. And these capacitors are measured in picofarads, so you take whatever value they display on their rating and do the appropriate conversion to whatever is the appropriate term. I actually have a video where I talk about scientific notation and engineering notation and the differences therein. All right, so there's the capacitor in. There we go. Just crop off those leads, make room for the next stage, which I think we'll put the ceramic oscillator in next. That's this little guy here. This guy is an 8 megahertz oscillator. I don't know if the letters show that well. It should. We're recording in 2.7K at 60 frames, by the way, so this is the highest quality video at least highest quality video quality-wise that I've ever released. But anyway, we've got... I can't even read those numbers. Yeah, it says 800, and then there's probably a date code there, so 8 megahertz. And that's going to go on the spot marked XTL1 or X1. Looks like that's right here. So we'll just place that, flip this over. Unfortunately, I don't have a high enough field of view here to be able to use my third hand, which I actually brought with me. Hopefully I'll be able to make a slightly better workspace for myself in the future. I'll be releasing a vlog about what's been going on later on this week. So I'll have to figure out exactly what I'm going to do about everything. But the channel is not going to die. I'm going to keep releasing stuff no matter what goes on. It just might be sporadic and improvised like this. On the subject of interesting things happening, actually I'll get on that once I have a bunch of similar components that I can just solder together while I talk. Let's see. What else do we have here? We do have another resistor here, but we actually won't be using this. This resistor here is a 10k ohm resistor. That you can see that with the brown, black, orange. So that's 1, 0, and then 3 zeros, so 10k. This is only if you're in Europe. You'll be putting this one on R3, but being as I'm not in Europe, we won't be using that, so we'll just put that off to the side. Let's see, we've got this little, probably power indicator LED. We've got a nice tall capacitor that's going to stand fairly proud of the board. Actually, let's do the switch and the IC socket next. Then we'll move on to the transistors, and I'll talk to you about this email I got from YouTube this morning while I solder those transistors, because they're all the same part, so I won't need to do much talking about them. Of course, a switch is just a switch. This will be the button we actuate in order to activate the device, which I just realized I haven't actually talked about what this thing does. Although some of you may have surmised from the name, it's called a TV Be Gone. It's a little prank product that can actually be a very useful tool in some circumstances, where this chip here, this is an AT-Tiny chip. It's basically a little tiny Arduino, and it's been pre-programmed with a program that cycles these IR emitter LEDs through the shutoff codes for every TV in existence. So originally they're released as a prank product. You know, you can make TVs mysteriously turn off and confuse your friends and stuff, but it also serves a useful purpose. I've heard of them being used in stores that sell a bunch of TVs. At the end of the day, they just click their TV Be Gone, and all of their TVs shut off. Let's see. We'll do the IC socket next. The socket has a little notch here that delineates for the positioning of pin 1. The socket isn't super important that you position pin 1 correctly, as long as you position the actual chip correctly. But for now, we'll just follow the standard conventions naturally. I really need to work on my umming. I say way too much when I'm recording. Let's see, I'll just put a little pressure on the bottom of that socket, make sure it's flush, and then we'll go ahead and solder the other pins. Now, I like to switch from pins on the opposite side of the socket when I'm soldering, just so that the heat doesn't build up inside the socket and melt it. I can't say I've ever had it happen but once, but after you melt an IC socket once, there's always that desire to make that not happen again. Alright, just crop off those leads, just kind of smooth down the back of this thing, and there we go. Let's see, what should we do next? Alright, I think, actually, no, I'm going to do the programming header next. This is actually pretty neat. It comes with an ICSP header, so that if you want, you can actually change the programming of the AT-Tiny chip in situ. As long as you have the appropriate equipment. Let's see. So again, we'll just flow solder onto one pin. Ow, 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 that's really warm. Come on. There we go. I'm sure I just went out of shot there for a bit, but I've shown you guys this trick before. You solder the one pin and then reflow the solder on it to make sure that everything is level, which it is. Oops. And then continue with the other pins. Now these header pins are actually really easy to melt, so you want to try to solder them fairly rapidly. There we go. And notice I solder at 300 degrees Celsius, as marked by my soldering iron there. Now, we won't be running into this problem with this particular project, but if I ever have a large ground plane or really thick wire that I have to solder, I could actually change the temperature of the soldering iron on the fly right here on the soldering iron. I don't have to reach over to a soldering station or anything. I really do like this. It doesn't have a lot of thermal mass. They've compensated that by putting the heater right up in the tip, which makes replacement tips for this soldering iron fairly expensive. But I've also noticed that the tips are quite resilient. For the 80 bucks you spend on that thing, and I've already done a very glowing review of the thing before, but I guess I'll talk a little bit more about it now. For the 80 some odd bucks they are a fairly decent soldering iron for the general hobbyist. I of course have not here, but I have my soldering station with the built-in heat gun, which is very important for certain projects. All right, now let's move on to this power diode here. Or this probably just illuminates when you click the button to kill the TVs. So we're just going to drop that right over here into D5. Come on, go in. There we go. Diodes are heat-sensitive devices, so these are another thing that you want to make sure you solder fairly rapidly. So we'll flow some solder onto the one pin. Reseat the diode so it's nice and flush. There we go. There. All right, so there's that. I keep seeing the cinch spot in the table that I just created with the soldering iron. I feel really bad about that. All right, so next, instructions. What's R2? I guess R2 isn't used. Alrighty, there's a spot here for an R2, but it doesn't appear to be utilized in this particular configuration. All right, so I'm going to go ahead and, well, let's do the capacitor next. I forgot to talk about polarity. I always talk about polarity with LEDs whenever I use one. There are two ways to tell polarity on an LED. One, it's probably not going to show up very well, but there will be a flat section on the side of the LED. That's the negative pole. And in most LEDs, there will be a longer lead, which in most LEDs denotes the positive terminal. Another way of telling the polarity of an LED is you'll notice that there's just a post on one side and there's sort of an anvil-shaped thing with a cup on top. The anvil-shaped thing with the cup is also the negative lead of the LED in most circumstances, but hopefully the more unusual LEDs that don't follow that format will have some sort of other marking on them to denote their polarity. But 99.9% of LEDs, the longer LED is the positive lead. It's the same thing with electrolytic capacitors. You've got two ways to tell the polarity. You've got the longer lead, which is positive, or there will be a stripe on the side that denotes the negative lead. I always remember that the lead that is plus sized is the positive side of the particular component. Anyway, so we're going to take, there's a little plus here on the board, so we're going to take the capacitor and just slide it down there. Get it fairly as flush to the board as we can. On the subject of improvisation, just off camera here, I've got a copper-coated scrubby pad that I bought at a dollar store, which does a fantastic job of cleaning the tip of a soldering iron. So if you're looking for a cheap and effective means of cleaning your soldering iron, go grab one of those. Make sure it's the copper-coated one. The iron ones are a little hard on the tip of the soldering iron, so the copper kind of softens the abrasive effect. Okay, so now we have 5 transistors that we need to place. There are these 4 here, which will be used for modulating the LEDs. And then we've got this other one that what do you do? It has something to do with the brain of the circuit, so not entirely sure what that's used for, but we'll go ahead and look at our guide here. Now, we've got these 4 guys here, and this one here. These 4 are PN2222A, which is just a very, very generic NPN transistor. Those will be the ones that are used for switching the LEDs, just down the side here. And then we've got this guy here, which is the PNP transistor. It's a PN2907. I like transistors that are packaged in this ammo belt format with the leads spread like that. Makes them a little easier to work with. Alright, so now you'll see here on the board there's actually sort of a half circle kind of thing that looks a little bit like the TO92 package, and that's how we'll determine how to plug the transistor in. Otherwise, it also says here EBC, which is emitter base collector, and most transistors have the same format, with the emitter being on the left and the base being in the center and the collector being on the right. But in case of any doubt, always look up the pinout, which can be easily and rapidly found with a simple Google search, which you would be amazed at how much preparation I do before a video, researching pinouts and stuff, just to make sure that things that I say on the channel are true, just in case I make a mistake. Which I still make mistakes, but I always try to correct them right away. They aren't all perfect. There we go. Transistors are also heat-sensitive equipment, which this will seem a little counterintuitive, but a hotter soldering iron, for shorter, will be less likely to cause damage than a cooler soldering iron, in which you'll be struggling to flow the solder onto the leads. I've found that 300 is kind of a sweet spot for that sort of soldering. So anyway, let's move on to the other transistors here. I'll pull them off of the card here. And while I'm soldering these, I'm going to talk to you guys about an email I received from YouTube today, or this morning. Let's see, it's right over here. Gadget Boy, today we are announcing changes to the YouTube Partner Program. While our goal remains to keep the YouTube Partner Program open to as many channels as possible, we recognize we need more safeguards in place to protect creator revenue across the YouTube ecosystem. Of course, whenever somebody opens up with something like that, you're like, oh crap, what's it going to do to me? So, going on further into the email, I'm just going to socket this in here. That's going to be a little awkward, but whatever. What's changing? Under the new eligibility requirements announced today, your YouTube channel, Gadget Boy, is no longer eligible for monetization because it doesn't meet the new threshold of 4,000 hours of watch time and 1,000 subscribers. As a result, your channel will lose access to all monetization tools and features associated with the YouTube Partner Program on February 20, 2018, unless you surpass this threshold in the next 30 days. Accordingly, this email serves as 30 days notice that your YouTube Partner Program terms are terminated. And then it goes on to talk about, there we go, their Creator Academy and Help Center and Creator Site, yada yada yada. And then as soon as your channel reaches this threshold, it will be reviewed to make sure it adheres to our policies and guidelines, and if so, monetization will be re-enabled. So I find myself now in the unenviable position of having to beg for subscribers again. I don't like having to do that. I already had to do it back when I first started my channel, back when you only needed 100 subscribers to monetize your channel. And now we need 1,000. And 4,000 hours of watch time in the past 12 months is a lot of watch time. Let me see. I'm just gonna quickly go to my channel here. There we go. Let's pull up our stats for the past year. Bear with me a second. All right, analytics. Overview. Let's see. In the last year, 2017, my average watch time is 212,437 minutes. I'll go over to my calculator here. 212,437 minutes divided by 60 is actually not bad. 3,500 hours watch time. So that's not too bad. Only need another 500 hours of watch time. Oh, you can see here the soldering iron goes into low power mode if I leave it alone, and then it heats up as soon as I pick it up because it's got an accelerometer in it. Anyway, so the watch time actually doesn't seem like too big of a hurdle to overcome, given that last year, with just a partial year of doing YouTube, I got 3,500 hours of watch time. But it's 1,000 subscribers that's going to be a bit of a challenge. Now, in the discussion threads that have opened up regarding this situation, a lot of creators are going, hey, if you subscribe to my channel, I'll subscribe to your channel, and we'll build up our subscriber count that way. Well, I'm afraid that's not going to work. YouTube is probably going to notice people doing that, and they can actually unsubscribe or penalize your channel if you're trying to circumvent their rules. So for any creators that happen to watch this that are planning to try to do something like that, I would advise against it. Now, continuing on the subject of being demonetized and departnered, that puts the channel at a very severe disadvantage, because when people are doing searches on YouTube, let's say for this TS100 soldering iron, preference is going to be shown by the YouTube search algorithm for channels that are monetized. So although I have done a review for the TS100 soldering iron, other people have as well, other larger channels with monetization and more subscribers and yada yada yada, which means that I might have a chance that my channel will be passed over by the search algorithm, which causes problems in that in order to gain subscribers, people need to see my channel in search results, and my channel isn't going to be ending up in search results because it's not monetized and I'm not part of the partner program. And thus lies the problem with the way things are. I understand why YouTube is doing this new approach. It is an excellent way of preventing channel counterfeiting, which is something you see on the really big channels like Markiplier, PewDiePie, Jacksepticeye. They're channels that I follow because I'm also a gamer. There are fake Markiplier channels out there that will actually steal videos when he uploads them and then re-upload them with the exact same description, the exact same tag. And what they do is they try to steal his views by re-uploading his videos. And it's a huge problem on YouTube. And I can understand why the YouTube overlords would want to squelch that, but it's also going to cause a lot of problems for smaller channels like me, like I've already said. So what I'm gonna have to ask everybody that watches these videos is to please subscribe if you haven't already subscribed. I really hate having to say those words. I don't like having to beg for subscriptions. Share it with your friends if you've got friends that are interested in tech things, or maybe just want to learn more about electronics. There are better channels out there than mine, of course. They're the channels that inspired me to begin YouTube, such as Big Clive or Julian Eyelet or Practical Engineering. They're all fantastic channels, really great guys, a lot of fun to watch. But yeah, just if you like what I do here, please share it with your friends if they have any sort of interest in these things, and we'll see if we can hopefully build me up to 1,000 subscribers, and then I'll stop begging for subscribers again. But for now, it looks like I'm stuck begging. Anyway, we're on to the final phase of building this thing. The transistors are all in. Now we're going to put the LEDs in. Now the way these LEDs are going to be mounted is, rather than putting them through the board, I'm going to mount them flush on these nice long pads that they've given us. So I've pre-soldered the pads there, and then we're just gonna, let's have a look here. Alright, so just okay. We're gonna crop these leads off like so. Oop, I'm out of shot, sorry. I'm gonna have to relearn my shot angles and everything now. There we go. And now, because I've cropped off the positive lead, actually I ended up making it a little bit longer anyway. Now we're gonna go through a slightly, this is going to be a little challenging without my third hand, but let's see what we can do here. I'll just reflow that solder onto the lead. There we go. And let's see. If anybody that's watching these channels has experience in working with GoPros and has any advice for using one in the capacity that I am, feel free to leave comments. I will take everything, any advice that is given. Feel free to leave little mentions if you feel it's out of focus or think that there's something I could do to do a better job here. Please let me know. Let's see, I'm going to borrow, actually, I'm going to borrow my roll of solder here, just to elevate this a little bit to make this process a little simpler. There's a big shine coming off of my improvised light. There we go. Okay, so now we're going back to the positive lead here. We're just going to flow this on. Right now I'm using the integrated microphone on the camera, so it'll be interesting to see how well that audio comes out. There we go. So I'm soldering these on the way it looks in the image. We're putting the two focused LEDs in the middle and the wide beam LEDs on the outside. But from a brief glance at the traces, I don't think it really matters how you position the LEDs, as long as they're on there, because they're all being, oop, I lead. They're all being switched at the same frequencies and being pulsed at the same rates. So they're all the same. But just for aesthetic purposes, we're putting the two focused LEDs here in the center. There we go. Had the soldering iron on that a little longer than I would have liked, but whatever. And one more LED. Clip, and clip that one a little bit longer just so I don't lose track of the negative lead. And reflow the solder. There we go. All right, now we'll get this back out of shot because it's just cluttering up the view. Use my channel logo to try to clean up here. That's a bit of a disadvantage to this silicone boards there, as that little bits stick to them, which in some ways is an advantage, but when I'm trying to sweep things out of the way, it makes it a little bit more difficult. Anyway, we'll just flow some solder here. There we go. And here. And here. And here. There we go. And that's basically the entire thing built. We've got the LEDs soldered on. They're not perfectly level, but they'll do. Last but not least, we'll very carefully, because these are always thinner than the leads are when they're manufactured, we're just going to squeeze those leads together just a little bit. Make them a little straighter so that it goes into the socket a little easier. There's a little dot here denoting pin 1. So we'll put that dot on the same end as the notch of the IC socket, which we aligned with the notch on the PCB, so that that's aligned correctly. Otherwise, we put 3 to 5 volts up one of the data lines and we destroy the IC. So always be careful to align your chips correctly. It won't always destroy the IC. Several times on the channel, actually, I have accidentally put an IC in backwards, but you really don't want to do that for the sake of, you know, trying not to destroy your integrated circuit. Anyway, so the next part of the process here, we have to mount the battery pack. Now, the way I'm thinking I want to do this is, I think I kind of want to mount it like this, so that the LEDs are hanging off the edge of the battery pack there, and you can just hold it like this and give it a click. So the kit also came with a chunk of double-sided foamy tape here. So I'm just gonna peel that free. I keep pulling out of shot. Right now this camera is very close to the workbench. That may cause focus issues, but we'll have to see. I don't want to have to get fancy lenses for the GoPro, but I may end up having to, depending on how this ends up working out. So we'll just put the double-sided foamy tape there on the bottom, and then we'll peel off the other protective layer. There we go. And then we'll just I don't like how I did this, because I should have done the power cables first. And bugger. Okay, alright, so what I'm gonna do then is turn that over, and then we're gonna crop these off just a little bit here, right about there, let's say. and then spread them out, and I'll just cheat a little bit here on the stripping of them. This is not the recommended method of stripping because of exactly what I just did. Joe bugger. Well, I may have just screwed this whole thing up by cropping that too short. Ah, brilliant, Chris. Excellently done. Very well done. Okay. There we go. Now let's see. They've got the positive lead and the negative lead shifted around here. I'm gonna have to crop this one down a little bit too, carefully. It does not have a repeat. There we go. All right, so we're gonna thread the positive wires through there. Oh, no. And we'll slot the negative wire through there. Yeah, I pretty much ruined this. Well, I didn't ruin it. It's still gonna work fine. It's just gonna look bad. Just got a little ahead of myself there. A little too hasty. There we go. Alright, so now the power is in. Now that that's actually soldered in, I can manhandle this around a little bit. It's going to be off-center. Wow, that's going to bother me. I'll have to fix this later. Right now we just want it to be functional though. I'll put a new battery pack on it later. Alrighty, so there we go. Now we just need 2 AA batteries. Hang on a second, I'll be right back. Alright, and I'm back with batteries. Let's see. We'll slip these in here. Bulk. And bulk. And then if we push... Oh. Okay, we've got a... Can you see that? Got a blinking LED. Wonder what happens when we push the button. It stops blinking. Huh. I wonder if there are more steps. Let's quickly solder it. Yeah, we already soldered it. Test it. With the battery in, make sure the green LED blinks after you press the power button. Oh, I forgot about that. Let's see. Well, that's disheartening. Something isn't working. I'll be right back. Okay, and I'm back. Oop, I think I bumped my camera or something. So it turns out that I wasn't... Sorry, headphone users. It turns out that everything was fine. It just seems that the GoPro doesn't see infrared, which is kind of interesting. So you can see the lights blinking there. That means that the program is actually running. I'm going to grab my phone here, and hopefully we'll be able to actually demonstrate what's going on here. If I hold this in front of my phone, you can see the LEDs are pulsing. Because most digital cameras see infrared. But apparently the GoPro doesn't, and that's kind of interesting. So that's it working. There's only one TV in the house, so I'm gonna have to test it on that one and see what happens. Actually, I'll be right back again. Alright, I'm back again. So basically, I just ran off into the living room and tested the TV Be Gone on the TV in there. Now, my expectations were a little bit crushed because I was expecting to be able to point it at the TV, click it, and have it immediately shut off the TV. But it takes a couple of seconds, it seems, to cycle through the codes. I thought it would, fire them off really, really super fast and then shut off all the TVs. But it seems like it kind of plods through them. So it doesn't happen as fast as I would like, but it worked. So there we have it. That's the TV Be Gone. If you liked, hit that like button, which actually does nothing for me monetarily. It just tells me that you liked the video. That's the only effect a like has. Please subscribe if you haven't already. There should be a dot somewhere around here for you to do that. I'll put a video that YouTube seems to think you'll like here. And yeah, any questions in the comments below, and we'll see you in the next video. Bye-bye.